Hello. In this lesson, you'll create a Python program to traverse a linked list. I've provided a program sample which creates the linked list as a 2D array. So that's already done for you. And then you're going to add code to that program to traverse the linked list. Remember that traversing any data structure means you visit every data location. And what we'll do is print out the data at each location. And then as you see it printed out, that will prove to you that your program's working right. So here's a suggestion about how you might like to use this video. You can watch it all the way through once. Don't do any coding, just watch it. It's up to you. Then I suggest you watch it again, and this time press pause at each slide, at least at the slides where you write some program code. And then as you're watching it, just write the program code and run it to check that you're getting the same results as what I see, as what I show you. And then at the end, you can try some extension exercises, which is to practice your skills. These are just suggestions, so you use the video the way that suits you best. Do you remember this? That's the 2D array that we looked at last time, and we've seen that you can use this 2D array to represent a linked list. Each location stores two values. The name for that is a node. The node stores some data. That's the first value stored at that location. And the second value is a pointer. The pointer is just an integer, but it tells the computer where to go to next for the next item in the linked list. So now we're going to make that using Python. So there's the array. I've put it there. It's slightly smaller, but at the top so that you can refer to it. And here's the code that makes that 2D array in Python. You can see it's just got the same value. So the first node is a letter A and the number 6, then the letter H and a number 3, and so on. It's a list of lists, which is what a 2D array looks like in Python. And I've used the Python keyword none to show when there's an empty part of one of the lists, any of the lists. So the first line that you've got to add is this line. That sets up a variable. I've called it pointer. You could use the little letter I if you wanted, but I think pointer's just clearer. And I'm setting it to 0. We have to tell the computer where the linked list starts. So the header of the linked list is node 0, the node in location 0. So I've created a variable, and that's just to tell the computer where to start. So it starts at location 0. Location 0 is a node. It's got two values in it. So I've stored that little list. The list is the letter A and the number 6. And I've stored that as a new variable called node. And then in my last line, I print the node. So you can write that program now. And when you run the program, you'll see that output, the letter A and the number 6. So we've put the pointer to the first node. We've stored that as a variable with the appropriate name of node, and then we're going to print it out. Now, normally we don't want to print the whole node because the second value is the pointer, and that's not part of the data. So normally we just want to print out the data part of the node. So I've set up a variable, I've called it data, and I'm storing the first value in the node and then printing it out. Now do be careful here. Node square brackets 0 doesn't mean node number 0. It means go to the current node and print out the first value in that node, which has the index number 0. So looking in the node that's got A and 6 in it, store the first of those two values, the A, as a variable called data, and then print that data. And then finally, we want to go from that node to the next node. So for that, I need the second value that's stored in that node, because the second value is the pointer. So I've created a variable. Sorry, I haven't created a variable. I've overwritten the variable pointer with the value that's in the next part of the node. So node square brackets 1. Remember, that does not mean node number 1. It means we've got a node. We're looking at the second value. Because of the way Python works, the second value is called 1. So node square brackets 1 is a number. It's the number 6, and we're saving it as a variable called pointer. Basically, that overwrites the old value, which was 0. That means that the new node equals a square brackets pointer, it's no longer 1, it's node 6. Because pointer is storing the value 6, and we've gone to the array element number 6. So the new node stores the value b and the value 2. Try writing that program now and see how you get on. Now, we don't really want to just print out one value and then hop on to the next value and then the program stops. We want to keep doing that. In fact, you can see that we're going to be constantly overwriting the pointer and moving to the next node. So all of these lines need to go inside a loop of some sort. The only line that doesn't go into the loop is the starting line, where we start with the pointer at 0. But everything else we just want to keep repeating until we get to the end of the linked list. Now, what kind of loop structure do we need to use? Just a think about that. See if you can figure it out before going on to the next slide, where I will tell you. There are two kinds of loop: a while loop and a for loop. So we need to use a while loop. We don't know how long the linked list is. We certainly can't count the length of the array, because the array can have empty nodes in it, or it might have more than one linked list stored in the same array. So we can't just count through the array, and that means we can't use a for loop. So we're going to use a while loop that just goes on as long as it can. When does it have to stop? Well, it will eventually get to a node that doesn't have a pointer. And when it gets to that, that means the linked list that's the end of the linked list. So I've set up a while loop while the pointer isn't none. None is that Python keyword that just means a missing value. So as long as the pointer isn't missing, keep on going. Keep going, following the pointers to the next node, to the next node, to the next node, and print out the data value each time. So do you want to try that now? Set up that, add that code, and run your program, and you should find it works fine. So now I'm just going to take time to go through this program that you've just written line by line, because the concepts that we're going to use throughout the rest of the linked list come up here, and I want you to get them right. I've got the array at the top of the screen so that you can see what we're referring to. So the first line of the program is pretty straightforward. I create a variable, I call it pointer, and I give it an integer value which tells the computer where the first node is. Obviously, it could be anywhere, and this linked list starts at 0. So pointer equals 0. And then I'm going to loop all my other commands while the pointer has got any value in it at all. And so it will keep going until it gets to an empty value, none. And then the next line, I create a variable called node, and I take whatever is in the array at the position of the pointer. So whatever I find there, I'm going to store it as a variable called node, and there it is. The node at position 0 is a little list that stores the letter A and the integer 6. Now, next, I'm going to take the data from that node. So node 0 there, it's really important. That does not mean node 0 of the array. It means value 0 of the current node. Value 0, that means the first value. So it means the letter A. And then the next line, print that data. It will print the letter A. So I've taken the first value of the node, the letter A, and I've stored it as a variable called data, and then I'm going to print that data. Remember, that's how we check that we're traversing the array correctly. We print out all the data values. Okay, so we're at a node. As it happens, we're at node 0. And the next thing we want to do is reset the pointer. So the pointer is the second value in the node. So it's node square brackets 1. Do be careful about that. It doesn't mean node number 1 or the node at position 1 of the array. It doesn't mean anything like that. It means we've got a node. Now look at the second value in the node. Remember, Python starts counting at 0, so the second value in the node is called node square brackets 1. Okay, so that's the 6. So the pointer is now storing the number 6. It was storing the number 0, and now it's storing the number 6. We've overwritten the pointer with the value at the node. And that means that we can continue, go back to the top of the loop again, check whether our pointer has the value none. It doesn't. We've got a value for the pointer, so we can go through all those lines again. I'm not going to do it again, but you might think, what happens at each one of those lines now? What's the new node? What is the new data? What is the new pointer? That will continue until you've gone through the whole array. So that's it. That's me done for the code. So what you need to do is open the Python program or copy the code on the screen previously, and then add code to traverse the linked list from location 0 and check what your output is. And then if you've got that working, change just the first line of the program so that the pointer starts at 1 instead of 0, and you should get a completely different output. So try that. And then if you've still got time and you want more practice, make a completely new program with a completely new linked list. You can choose the data. You can make it print out any message or letters that you want. And before we stop, let's just check back to a theory point. When we're working with an array, we can go directly to any data value in the array by giving the number of that data location. So the big O value is 1. We go straight there. But if we're using a linked list, for any value in the list apart from the header, we can only get there by following the links from node to node, which is up to n links, where n is the length of the linked list. So accessing a value in a linked list has a big O value of n. Obviously, that's a disadvantage compared to an array. There are some advantages to linked lists, and we'll find out about those in future lessons. But for now, just remember that learning point and write your program. Join me for the next lesson. Cheerio.